All right, we are now ready to look at subtracting polynomials since we've looked at adding polynomials. So before we start, I want to remind you of how we subtracted integers. If you remember, we determined that when we subtract an integer, that was the same as adding the opposite integer. So my question is subtracting a polynomial the same as adding the opposite polynomial? So we'll explore a little bit using our model. We have a 3x minus 2, so I've modeled that, and I want to take away from that negative 2x is plus 1. Now the problem is, when I look here, we'll say you've got the 3x minus 2, and I want you to give to me a negative 2x plus 1. And when you give it to me, we'll put it under that green line. Now the problem is you don't have any negative x tiles to give me. But if we use 0 pairs, we can get some. Because as long as when I put in one positive x, if I put in a negative x, together that's a 0 pair, and it gives me 0, so it's still 3x that you have there. If I do it a second time, now I have two negative x tiles. But with the 0 pairs, right, I also have two more positives, so it's still 3x's. Now the question a student will ask me is, well, how many times do I have to do that? And you have to do it enough so that you can give away the tiles that you're being asked to give away. So if I move over now to my ones, you have negative 2 ones, or negative 2 1 tiles. I want a positive one. So, well, you can put in a positive one provided you use a 0 pair and put in a negative one. So now we are ready, and you can actually give me those things. All right, so you're going to give me 2 negative x tiles, and you're going to give me a positive 1 tile. Now when you do that, what are you left with? Well, you are left with 2 positive x tiles and a negative 1 tile. See, it's the opposite of what you gave me. So we end up with, as an addition, or as a sentence here, if I take 3x minus 2 and subtract from it negative 2x plus 1, you're going to end up with, if you count them all up now, 5 x's and minus 3 1's. So I'm going to let someone else's voice be heard here for a moment, so I'm just going to take the mic off so you can hear them. This is a video that's included within our grade 9 textbook.
We can use algebra tiles to model 3x squared minus 4x minus 2x squared minus 6x. We start by modeling 3x squared minus 4x. To subtract 2x squared minus 6x, we need to take away 2x squared tiles and 6 negative x tiles, but we only have 4 negative x tiles. We need 2 more negative x tiles, so we add 2 0 pairs of x tiles. Now we can take away the tiles for 2x squared minus 6x. The remaining tiles represent x squared plus 2x. So 3x squared minus 4x minus 2x squared minus 6x equals x squared plus 2x.
All right, let me just put my mic back on. Let's look at a second example. All right, so now I have a trinomial. Right? I have one trinomial, I'm subtracting a second trinomial. So you have x squared, 1 positive x squared, 1 negative x, and 2 positive x's. I want you to give me from there now I'm going to change this question just slightly, sorry. I'm going to change this to a negative one here. Because here's what I want you to give me. I want you to give me 2 negative x squared tiles, a positive 3x tiles, and a negative 1 tile. So how do we do that? Well, again, if you look, you've got a positive x squared tile. You don't have any negative x squared tiles. So we use 0 pairs. Here's one 0 pair involving x squared tiles. Here's a second 0 pair. Okay. Now you would have enough, I'm just going to slide this over, you would have enough that you can give me 2 negative x squared tiles. Now you have a negative x, and I want 3 positives. Well, that's a problem, but we can fix that with more 0 pairs. Here's one 0 pair. Here's a second 0 pair. Now, am I going to need a third? Well, do you have positive 3? No, you only have positive 2, so I put in another 0 pair. Now you have enough. Yeah, you have 3 positive x tiles there. Okay, and a negative 1. Well, you only have positives, so again, I'm going to put in another 0 pair, and now we are able to, you're able to give me what I would like to have. So let's do that. Now you give me negative 2x squared tiles. You end up with positive 2x squared tiles. You give me positive 3x tiles. You end up with negative 3x tiles. You give me a negative 1, you end up with a positive 1 tile. So when we put those together, you see what happens. You end up with, if you take x squared minus x plus 2, subtract this, you end up getting the opposite back. And when you combine them, 3x squareds minus 4x's and plus 3. Now, the question is, how do we do that without the tiles? Well, here are the steps that we're going to follow. We've shown that when I subtract a polynomial, that's the same as adding the opposite polynomial. So that's the first thing I want you to do. I want you to switch this, and I'm going to take just a slightly different approach, okay, from your notes, but it'll work out to the same answer, so don't worry about that. First thing I'm going to do, this first polynomial is not being subtracted, so I just leave it. This one is, so I turn every term into its opposite. This was a positive 2. When you give me a positive 2x squared, you're going to end up with 2 negative x squared tiles. When you give me a negative 3x, you're going to end up with a positive 3x tiles. When you give me a negative 1, you're going to end up with a positive 1 tile. So now, since we're adding, just like we did last section, we drop our brackets. And now we can combine like terms. An x squared and a negative 2x squared, a negative x, and a positive 3, a positive 3, and a positive 1. So when I combine these, one of the positive x squareds will cancel with one of the negative x squareds. I end up with a negative 1 x squared, which we normally just write as negative x squared. A negative 2x and a positive 3x gives me a positive 1x. So again, I would just write it as a positive x. 3 and 1 gives me a 4. Okay. So one more without all the writing. Well, if I was to do this, all right, well, I know that the first one is just being added. I'm not subtracting that one, so I do not change that one to the opposite, but I'm subtracting that second binomial. So I'm going to change that to an addition, and everything in there becomes the opposite, because remember, when you give away negative 2a squareds, you end up with positive 2a squareds. And when you give away a positive 4, you end up with negative 4 units. So now I can drop my brackets, because it's all addition. Okay. And I really want to see that step, that first step. Okay, drop my brackets. Now I'm going to click like terms. 4a squareds and 2a squareds together are like terms. Negative 3a is a like term with, oh, there is no other a, so there's no other like terms. Plus 5 and negative 4 are like terms. So when I combine those, 4a squareds and 2a squareds gives me 6a squareds. Again, I add the coefficients, leave the variable part the same. Negative 3a and plus 1. Okay? So, big idea. When you're subtracting a polynomial, it's the same as adding the opposite polynomial. And so that's what you're going to do. You're going to change it to adding the opposite. All right? Good luck with that.